Hello guys, I welcome you to my YouTube channel. It's been a long while. So sorry for that silence and break, but I'm back and to continue with making my video series on different topics in physics. And today I'll be looking at this important topic, circular motion. Please, thank you very much for those of you that are still my subscribers. I want to encourage you to stay tuned, continue to stay tuned to the channel, and do talk to your friends about it. All right, so circular motion, how do we define that quickly? It is the motion of a body in a circle. Let's see, we have a track. This track can be a complete circle, as you can see in this diagram, or a track that is almost a circle. Could be an arc or a semicircle. As long as the body moves in such a path, we can describe the motion as being circular. And we have two types of circular motion, the horizontal circular motion and the vertical circular motion. We can also talk about uniform circular motion, that is the horizontal circular motion, whereby the body moves with a constant speed. That is said to be uniform circular motion in a horizontal circle. But motion in a vertical circle is always non-uniform, except it is made uniform, just depending on the scenario. Okay, so here we are going to look at the parameters that is used to describe circular motion. Parameters. Okay, let's say this is the center of this circle. I call that center O. And at the time t, or at t equals 0, we have a particle here at point A. Okay, let me draw this line. Of course, we call this line the radius, or the radius vector. So after some short time interval, this particle has moved from A to another point B. Okay, let me also draw this line, which also represents the radius of the circle. Now, we shall be seeing from here that number one, the linear distance covered by this body in the course of moving from point A to point B, it has described or covered a linear distance. Let me call that D. That linear distance D is equal to the length of the arc. That is arc length. And I'm sure your mathematics were taught how to calculate the length of an arc. So D equals theta, which is the angle described here, because this theta, very soon I'll explain it, describe it in much detail, what it represents, what it stands for. But for now, let's just take it as the angle subtended by this arc length AB measured in radian. So we have that over, and this theta is measured in radian, okay, not in degrees. And you know that 360 degrees, if you have not known that, you need to understand that 360 degrees is equivalent to 2 pi in radian. Radian is another system, unit of angle measure. You can measure angle in degrees, or it can be measured or given in radian. So 360 degrees is 2 pi radian. So I can replace that as a 2 pi radian times 2 pi times radius of the circle. Okay. Now we can cancel this so that the linear distance d equals the angular displacement theta, is what we call it here, multiplied by the radius r. Or I can define angular displacement as a linear or arc length over what? Radius of the circle. Okay, but my emphasis is on this equation. That is to say the linear distance covered from here to here is given as theta multiplied by this. And this theta again is the angular displacement. All right, again, I want to look at the linear displacement. We've seen the linear distance, or just the distance covered. How about the linear displacement of this body? Because this body moved from point A to B, it has covered a linear displacement. That is a straight line that links A to B. The length of this straight line is equal to the linear displacement of this body as it moved from point A to another point B along the circle. Okay, so which means if, for instance, the angle subtended by the arc AB or the angular displacement is 90 degrees. 90 degrees is same thing as pi over 2 radian. 90 degrees is same thing as pi over 2 radian. It means that the angle subtended at the center here is a right angle. I can fetch out that diagram. I have this, I fetch it out from that figure. I have this is my radius, this and that radius. This angle here is now theta over pi over 2, which is 90 degrees. This makes a right angle triangle. And by Pythagoras theorem, this is my AB. So, and the length of the line represents my displacement, linear displacement. So by Pythagoras, I have x squared is equal to r squared plus r squared. That gives me x squared is equal to 2r squared. So that my linear displacement is square root of 2 because square root of radius r squared is r. So that gives me the expression for linear displacement. So take note of that. There's a slight difference between linear distance covered, which is just the arc length, and the and the linear displacement, which is just a straight line that links point A to point B. Okay, number 3, we look at angular displacement. Now, this linear displacement, of course, whenever I talk about displacement in kinematics, displacement is always a vector quantity, meaning that it has both magnitude and direction. So for angular displacement, okay, I've said this before, but I'm coming back to it again so I can explain it properly. The symbol is theta measured in radian. And this angular displacement is also a vector quantity. Please note that, meaning that it has both magnitude and direction. So the angular displacement, that will define that it is defined as the angular distance, or it is defined as the angle that is turned through in a given time. So it is the angle that the particle turned in the course of moving in a circle. The angle described by the particle turned through by the particle in a given time. In a given time, not per unit time, or just in a given time interval, in a given time. Okay, so that's my definition for angular displacement. It's a vector quantity. What's the direction? If you have a body that moves in a circle like this, let's say it moves in this direction, the direction is given by the what we call right hand thumb rule. Direction is given by the right hand thumb rule. That is, if you have your right hand and then you hold it up like this, such that you can fold the four fingers like this and the thumb is pointing upward. So if the four fingers, rotate in the direction of the body, let's say this is anti-clockwise, it's rotating like this, then the thumb point outward in the direction of the direction of angular displacement. Okay, so that is it. That's the direction. So since the direction is, along the axis of rotation, let's see, for instance, this object is a flat disk rotating about this point. So it means that the direction of theta is along this point, the center of rotation, the axis of rotation. So that's why theta is always called the axial component. Axial, because of its direction. So it is called the axial component. Okay. All right. So that now again we can define theta. That is, the angular displacement can be defined, that is, as linear distance over radius of the circle. Okay, I can even use this one. I want to use D here to differentiate it from linear displacement over R. So this is how we define angular displacement. Now, what's a radian? Angular displacement of 1 radian, how do we define that? It means that this equals 1 radian when the linear distance d is equal to the radius of the circle. Okay? Okay, so we can say that 1 radian is that angle that is subtended by an arc. 1 radian is that angle that is subtended by an arc. 1 radian is that angle that is subtended by an arc. Okay, so we can say that 1 radian is that angle that is subtended by an arc. 1 radian is that angle that is subtended by an arc. Okay, so we can say that 1 radian is that angle that is subtended by an arc. 1 radian is that angle that is subtended by an arc. Okay, so we can say that 1 radian is that angle that is subtended by an arc. 1 radian is that angle that is subtended by an arc. Okay, so we can say that 1 radian is that angle that is subtended by an arc. 1 radian is that angle that is subtended by an arc. Okay, so we can say that 1 radian is that angle that is subtended by an arc. 1 radian is that angle that is subtended by an arc. Okay, so we can say that 1 radian is that angle that is subtended by an arc. Okay, so we can say that 1 radian is that angle that is subtended by an arc. Okay, so we can say that 1 radian is that that has a length or whose length is equal to the radius of the circle. So it is the angle that an arc subtends at the center whose length is equal to the radius of the circle. That is 1 radian. Okay, so that when I have this, if the body starts from here, for instance, and makes a complete cycle, let's say this is starting point at point A, it goes round the circle once. So the total angular displacement covered is 2 pi radian, just like we know that angle in a circle is 360. So when it starts from point A, goes round maybe in this direction, and is back to the same point A, it has covered a total angular displacement as equal to 2 pi radian. How about if it makes a number of revolutions? A revolution is simply a cycle. If it makes, let's say, 20 revolutions in a given time, what is the total angular displacement? It is 2 pi times 20. So when it makes n number of revolutions, so the total angular displacement is 2 pi n in radian. All right, so we have seen that now, angular displacement, that's a vector quantity, and we've seen how to define a radian and how to calculate or determine the total angular displacement when a body moves a number of times, completing a number of cycles or revolutions. Now, the next term we are going to look at, still under the parameters of circular motion, is velocity or speed and velocity. Let me just call it speed and velocity. Now, under this, we're talking about number one, linear speed and velocity. Linear speed. Now, this linear speed, I also call it instantaneous speed of the body. Instantaneous speed. Now, when the body moves in a circle, in the case of uniform circular motion, the body moves in this circle with a constant speed. The speed v is said to be what? Constant. When the body moves in a uniform circular motion, the speed is said to be constant, meaning it's not changing. All right. So, and speed is a scalar. It has no direction. So that's why it's also can also call it instantaneous speed, because it's still the speed of the body at a given instant. Okay. Now for velocity, they call that is a vector quantity for linear velocity. For linear velocity, it's a constant, it's a vector quantity, so to speak, and it has direction. So at this point, for instance, the body is at a point A. I'm going to draw a line at A, that is a tangent at A. Okay, so when the body moves to somewhere here, let's say point B, I'm going to also place a tangent. Recall that a tangent is just a line that touches one point on the circumference of a circle, or touches one point on an arc or a curve. Now, suppose the body is moving in this direction. It means that the direction of the body's motion at point A is the direction of the tangent at A. So which means the motion direction is along the tangent at A. At B, place an arrow here to indicate that the body moves like this. So the direction of this tangent is the direction of motion, the direction of speed of the body at point A. So it means that the body at point A has both magnitude and direction. The magnitude is just the speed, which is constant in the case of a uniform circular motion, and then the direction is this way. So when you combine speed and direction, that's velocity. The same thing applies at point B. So the speed is constant in magnitude at point B, but the direction at B is not the same as the direction at A. It means that the velocity at B would not be the same as the velocity of A or at A, because the directions are different. Recall that for a vector quantity, so if the velocity at A is VA and the velocity at point B is VB, now when the body goes from A to B, what is the velocity change of the body? It is given by velocity at B, which is final, minus VA. This is a change in velocity. It's also a vector quantity. Now, how do we add it vectorially? That is, want to find the change in velocity vectorially. Now, VB minus VA is the same thing as one of my videos. I explain how to add two vectors. The same thing as VB plus minus VA. That's to say it is the velocity of A, velocity of B, followed by the negative velocity of A. Because that's the same thing. So I'm going to take this my VA directed this way. My negative VA is going to be a velocity that is equal in magnitude to VA, but directed oppositely like this. So this is my minus VA. This is my VA. Okay, so I'll come here now. I'll start with B. B is directed this way. This is my VB. This is my VB. Then I'll connect the edge of B to the tail of A because it is B followed by negative A. This sign means followed by. So you start with B followed by A. That means it's going to be something like this. Followed by. Okay, this is my minus VA. You can see that this is same thing as is parallel to it. So this becomes my negative or my change in velocity.